In the summer of 1944, as the smoke of war spread across Europe, British forces encountered something that both impressed and infuriated their engineers. The German Panzerkampfwagen 5, better known as the Panther. It was sleek, powerful, and deadly accurate. Yet beneath its fearsome reputation lay a machine that revealed the contradictions of German engineering. Brilliance on paper, but often chaos in practice. When the first intact Panthers were captured in Normandy, British intelligence wasted no time transporting them back to England. They wanted to know how such a machine could outgun most Allied tanks, and whether it was truly the miracle weapon German propaganda claimed. The tank arrived at the military experimental establishment in Chertsey, covered in dust, its engine seized, and its armor scarred by battle. To the soldiers who had fought against it, this was a monster. To the engineers, it was a puzzle waiting to be solved. The initial inspection stunned them. The Panther was unlike anything they had ever examined. Its sloped armor, revolutionary at the time, gave it protection far greater than its thickness suggested. Its long 75mm KWK-42 gun could pierce Allied tanks at over 2 kilometers, while remaining remarkably precise. The welds were smooth, the steel hardened, and the suspension elegant. It looked like a masterpiece of mechanical art. But as they dug deeper, that admiration began to shift. The mechanics soon discovered that the Panther's beauty was deceptive. Every component, from the gearbox to the cooling system, was engineered with painstaking precision, but also with maddening fragility. It demanded perfection from those who built it and punished anyone who failed to meet that standard. British engineers, accustomed to the rugged, simple designs of their own tanks, such as the Cromwell or Churchill, were shocked. The Panther required constant care, like a race car forced to fight in a swamp. Even its engine, the Maybach HL230, though capable of immense power, was temperamental. The Panther's heavy weight pushed it beyond its limits, causing overheating and frequent fires. Its complex overlapping road wheels, a distinctive German feature, trapped mud and ice, turning maintenance into a nightmare. To change even one inner wheel, the outer layers had to be removed first, a process that could take hours in the field. For every minute the Panther spent moving, it seemed to spend 5 being repaired. What impressed the British most, however, was how much thought had gone into the wrong things. The interior of the Panther was cramped, difficult to access, and filled with fragile parts that seemed designed for workshops, not battlefields. Cables ran awkwardly, filters clogged easily, and even the simple act of draining the engine oil required disassembling several panels. It was a machine born from theoretical perfection, but utterly impractical under the brutal conditions of war. The testing teams began to see why so many Panthers had been abandoned intact in France. It wasn't always enemy fire that killed them. It was their own complexity. The British mechanics joked privately that the Panther might be the most dangerous tank in Europe, but only to its own crew. The Germans had built a weapon so intricate that it could barely survive the mud, dust, and chaos of the very front lines it was meant to dominate. And yet, there was no denying the intelligence behind it. When it worked, the Panther was deadly. Its optics were unmatched, its gun terrifyingly precise. On open ground, it could destroy nearly any Allied tank before they even got within range. It was the embodiment of German design philosophy, a blend of ambition, arrogance, and obsession with engineering superiority. But like much of the Reich's technology, it was a perfectionist's dream trapped in a realist's nightmare. The British report from Chertsey would later summarize the Panther with one line that captured its essence perfectly: brilliant in conception, disastrous in execution. It was a weapon that mirrored the war it had been built to fight: advanced, ambitious, and ultimately unsustainable. As the captured Panther sat under the gray English sky at Chertsey, British engineers began the long process of taking it apart piece by piece. Their goal was not just curiosity, but understanding, to see how a machine so advanced could also be so deeply flawed. What they found revealed the mindset of a nation that prized precision above practicality. The Maybach engine was the first major component examined. It was a marvel of craftsmanship. 12 cylinders of finely tuned German engineering, capable of propelling the 45-ton tank at nearly 30 miles per hour on paper. But when the British tried to restart it, the problems became obvious. The carburetors flooded easily, oil pressure fluctuated unpredictably, and the cooling system barely functioned without constant attention. The engine had been designed for a different world, one with endless spare parts and ideal conditions, not the dust and chaos of frontline warfare. Inside the engine compartment, the engineers noticed something else, a level of complexity that bordered on the absurd. Dozens of components were crammed together so tightly that even routine maintenance required removing large sections of armor. The mechanics joked that German crews must have needed surgical tools and infinite patience to keep the thing running. It wasn't a battlefield machine. It was a laboratory experiment sent to war. When they examined the transmission, the pattern repeated. The Panther's gearbox offered remarkable control, a 7-speed system allowing precise maneuvering at high speed. But the gears were fragile, the tolerances impossibly tight. Any dirt, misalignment, or lack of oil could seize the entire mechanism. Compared to the sturdy, forgiving transmissions of Allied tanks, it was like comparing a watch to a hammer. Brilliantly designed, yet utterly unsuited for the pounding it endured in combat. The suspension system fascinated and horrified the British in equal measure. The interleaved road wheels, stacked in overlapping layers, had given the Panther a smooth ride and excellent weight distribution. But they also trapped mud, ice, and stones until the entire suspension froze solid. In the Russian winter, this flaw had turned entire armored divisions into immobile targets. Even in the mild British climate, the testing crews had to pry mud out with crowbars after every short drive. The more they studied, the clearer the picture became. The Panther was a product of a nation that still believed wars could be won through perfect machines, through engineering brilliance rather than production efficiency. It was elegant but fragile, powerful but unreliable. For every Panther that fought, another sat idle, broken down, or waiting for parts. By contrast, the British and Americans had learned the opposite lesson. Their tanks were crude by comparison, but they worked. The Sherman might not have the Panther's range or armor, but it could cross rivers, climb rubble, and fight day after day without collapsing. It could be repaired quickly in the field, often with little more than a wrench and determination. The British began to see that Germany's greatest weakness wasn't lack of talent. It was an obsession with control. The final tests at Chertsey confirmed everything the engineers had suspected. During stress runs, the Panther's engine overheated repeatedly. The cooling fans struggled to keep up, and the temperature gauges spiked within minutes. The mechanics had to shut it down to prevent the engine from seizing. The transmission, too, began to grind and slip under strain. And when they tested its electrical systems, they found brittle wiring that shorted easily under vibration. By the time the test concluded, the British report was blunt. The Panther was a technological masterpiece that could not survive the reality of war. It was too complicated to build, too fragile to maintain, and too demanding to operate. For everyone that reached the battlefield, 3 more broke down on the way. And yet, as they stood before the machine, battered, burned, but still imposing, the engineers couldn't help but feel a kind of respect. The Panther had been born from genius, but it had died from overconfidence. It was the perfect symbol of Germany's wartime industry, magnificent but doomed by its own perfectionism. The British engineers continued their evaluation of the Panther with a deeper sense of fascination mixed with frustration. The more they dismantled the machine, the more they understood the philosophy that had shaped it, a mindset rooted not in practicality, but in pride. Every nut, bolt, and weld reflected the German obsession with precision, yet that same precision had become the very thing that doomed the tank on the battlefield. In the workshops of Chertsey, the Panther's components were laid out like the remains of a fallen giant. The engineers examined its turret, a formidable structure housing one of the deadliest guns of the war, the 75mm KWK 42L70. Its barrel was long, almost elegant in proportion, and its internal rifling so finely machined that the weapon could maintain exceptional accuracy even at long ranges. The optics were among the finest they had ever seen, far superior to those on British or American tanks. Through its Zeiss scope, the Panther could strike with uncanny precision. But this brilliance came with a hidden price. The gun's recoil system was extremely complex, with delicate seals, tight tolerances, and multiple moving parts that required regular maintenance. If one seal failed, the recoil could damage the entire mount. On the battlefield, this meant that a single hit to the turret, even a non-penetrating one, could render the gun useless. British testers noted that it was a gun made for skilled hands in controlled conditions, not the chaos of frontline combat. Then came the armor. The Panther's sloped frontal armor, 80 millimeters thick and sharply angled, had revolutionized tank design. British inspectors admitted it was genius. Sloping the plates increased effective thickness and caused enemy shells to deflect. In their own tests, they fired captured German 75 millimeter and Allied 17-pounder rounds at the Panther's glasses. Most ricocheted harmlessly away. Against the front, the Panther was nearly invincible. Yet its sides and rear told a different story. The armor there was thinner, just 40 to 50 millimeters, and crucially, vertical. When struck by Allied anti-tank weapons from the flank, it failed catastrophically. The engineers noted that while the Germans had focused on frontal engagements, real battles rarely offered such predictability. Tanks could be ambushed, flanked, or encircled. The Panther, for all its strength, was not forgiving of mistakes. One of the engineers compared it in his notes to a thoroughbred horse sent into a swamp. The Panther demanded conditions that no army could guarantee. Its suspension needed constant cleaning, its gears constant lubrication, its engine constant care. To keep a Panther operational required not only skill, but infrastructure, workshops, spare parts, and trained mechanics. By 1944, Germany had none of these in sufficient supply. When the British simulated field maintenance, the results were damning. Replacing a single damaged wheel took half a day. Removing the transmission required lifting the entire turret. Even basic operations, like changing the oil, demanded tools that field units didn't have. It was a machine built for engineers, not soldiers. Despite these flaws, the Panther's presence on the battlefield had been terrifying. British tank crews who faced it in Normandy described the dread of hearing its gunfire, a deep, resonant thunder that seemed to tear the air itself. Its shells could punch through a Sherman from over a mile away. But now, standing over its disassembled remains, the engineers realized that the fear it inspired had hidden its weaknesses. It was a weapon designed to win duels, not wars. The British also compared the Panther to their own upcoming designs, the Comet and Centurion. Both were being built with lessons learned from fighting German armor. Where the Panther was overcomplicated, the new British tanks were balanced, durable, maintainable, and built for sustained operations. The engineers saw in those designs the future of armored warfare. Practicality over perfection, reliability over complexity. By the time the last report for that month was written, one sentence stood out above all others. The Panther represents the genius and the downfall of German engineering. A weapon that sought flawlessness and found fragility. When autumn rains swept across England, turning the testing grounds at Chertsey into thick mud, the British engineers decided to see how the Panther performed in real terrain. Not on a clean floor or maintenance pad, but in the kind of ground it was meant to dominate. They towed the repaired German machine onto the proving field and prepared for a series of mobility trials. What followed confirmed everything they had begun to suspect. At first glance, the Panther looked at home in the mud. Its wide tracks spread the weight evenly, giving it impressive traction on firm ground. The first few runs went smoothly. The engine growled with deep power, the suspension absorbed bumps effortlessly, and the turret turned with smooth precision. The mechanics, watching from a safe distance, couldn't deny the elegance of its movement. But then, as the mud deepened, the flaws began to surface. The heavy hull started to sink. The interleaved road wheels, so intricate in design, packed with wet clay and grass until they could barely move. The weight of the tank, nearly 45 tons, pressed it into the earth like a stone. The Maybach engine strained, its revolutions rising, the exhaust pouring black smoke. Within minutes, the temperature gauges began to climb. The Panther's cooling system, already a known weakness, struggled to dissipate the heat. The engineers shut it down before it could seize. Once stuck, recovering it was a nightmare. The British used two Churchill ARV recovery vehicles, both straining to pull the German tank free. Even this small demonstration mirrored what had happened countless times on the front, a tank so powerful that it often became its own worst enemy. In the mud of Russia and France, Panthers had been abandoned by their own crews after mechanical failures. Now in England, that history repeated itself. Back in the workshop, the mechanics tore down the transmission for inspection. The damage was telling. Gears scored and cracked, oil lines blocked with debris, and the clutch plates showing signs of intense wear. The engineers noted that the Panther's drivetrain, though brilliantly designed for precision, was far too delicate for rough terrain. Even minor shocks could cause lasting harm. Its makers had built it to perform perfectly, not to endure imperfection. They began comparing their notes with captured German documents recovered from Normandy. Those records told a familiar story. Countless reports from field units complaining of breakdowns, delays, and shortages of spare parts. Some Panther battalions reported losing half their tanks to mechanical failure before even reaching the battlefield. For the British, these reports confirmed what their tests showed. The Panther's engineering brilliance was self-defeating. In their debriefings, the engineers reflected on the cultural difference behind the designs. British and American tanks were built with soldiers in mind, machines that could be operated, repaired, and maintained by crews with limited training. The German approach was the opposite. The Panther was built as if its designers expected every crewman to be an engineer, every mechanic a master craftsman. In a laboratory, it might have been perfect. In war, it was a burden. When the tank was reassembled for another test run, the engineers tried one more challenge, a long-distance endurance drive across varied terrain. The Panther lasted less than 2 hours before smoke began to pour from its rear deck. A cooling fan belt had snapped, the oil temperature soared, and one of the final drives failed catastrophically. The trial ended abruptly, the tank once again immobilized. Standing around the smoking wreck, the engineers could only shake their heads. It was clear why the Germans, despite their technical genius, had lost the war of machines. They had built marvels that could not be maintained in the field, and no amount of training or bravery could compensate for that. The Panther, though deadly, was too ambitious for its own good, a machine born of overconfidence and desperation. As the autumn light faded, the British team recorded their findings. The final note of the day read, "A tank that tries to be perfect in every way will fail in the one that matters most, to keep fighting." Winter arrived in England, bringing with it cold winds and rain that turned the testing grounds into a mirror of Europe's battlefields. The British engineers continued their study of the Panther, now focused less on its performance and more on its construction, the fine details that revealed the mindset of its creators. They wanted to know not just how the tank failed, but why it had been designed this way in the first place. Inside the workshops, the Panther lay partially disassembled once again. Its massive gun rested on a wooden frame, its turret lifted aside, and its armor plates exposed to inspection. What struck the engineers first was the sheer care that had gone into its production. Every weld line was neat, every plate precisely cut, every fitting secured with high-grade steel fasteners. Compared to the rough, almost hurried construction of British and American tanks, this level of craftsmanship was extraordinary, but it was also damning. Each one of those careful touches represented time. Time that Germany didn't have, labor that could have been spent producing more tanks, and resources that were running out. To build one, Panther required the same industrial effort as 3 or 4 Shermans or T-34s. The British team realized that, for all its elegance, the Panther had been a strategic blunder from the very start. The engineers moved next to the suspension system, a marvel of over-engineering. Its overlapping road wheels gave the Panther excellent weight distribution and a smooth ride, but at a staggering cost in maintenance. Each wheel was made with such precision that even slight misalignment caused vibration and wear. Replacing one damaged wheel often meant removing 10 others. In muddy or freezing conditions, the system froze solid, trapping the tank until the crew could spend hours, sometimes days, cleaning it out. Reports from German documents supported this. Frontline crews had written bitterly about how their tanks failed before battle, not because of enemy fire, but because of frozen mud, jammed bearings, or seized engines. The Panther, the engineers concluded, was a perfect machine built for an imperfect world. It was meant to fight wars of theory, not wars of endurance. Attention then turned to its armor. The British metallurgists tested samples from the Panther's plates and found them to be of very high quality, well-tempered and carefully hardened. But by 1944, Germany had begun to cut corners. Wartime shortages forced factories to use lower-grade steel, leading to brittle armor that cracked under impact. The engineers noted these differences, recognizing the decline of German industrial capacity. Even the best designs meant little when the materials were inferior. And yet, even as they criticized it, they couldn't help but admire it. The Panther embodied a kind of mechanical artistry, a combination of intelligence, arrogance, and desperation. It was built by a nation that refused to compromise, even as the war demanded exactly that. Every part of the tank, from its turret ring to its cooling fans, was a statement of intent. Germany would win through superior technology, even if it meant sacrificing everything else. The British comparison to their own tanks was striking. The Cromwell and Churchill were simple, sturdy, and forgiving. They broke down, yes, but they were designed to be fixed quickly. The Comet, entering service that same year, reflected this philosophy perfectly. Speed, reliability, and practicality over mechanical brilliance. The engineers realized that this was the key difference between the two sides. Germany sought perfection, Britain sought endurance, and in the end, endurance had won. As the day's test concluded, the Panther stood silent once more, its dark hull streaked with rain and grease. The British chief engineer looked over the notes, hundreds of pages of observations, sketches, and diagrams, and recognized that this tank, for all its flaws, had changed the way the Allies thought about design. Its sloped armor would inspire future generations. Its gun would influence post-war development, but its overcomplication would serve as a warning forever. The engineers recorded their conclusion that evening, summing up their months of work in one sentence. The Panther was not defeated by the enemy, it was defeated by its own perfection. The more the British engineers studied the Panther, the clearer its story became. A tale not only of mechanical ingenuity, but also of the downfall of an entire philosophy of warfare. By early 1945, they had stripped, rebuilt, and run the tank more times than its original crew likely ever had. What they found beneath the armor and steel was the mind of an engineer's dream and a soldier's nightmare. The Panther's interior was a testament to precision gone mad. Every lever, gauge, and mechanism was beautifully machined, but cramped together with no thought for practicality. The driver's seat was surrounded by control rods, pipes, and wiring that snaked through the hull like veins. Even the simple act of accessing a fuse or replacing a part required removing panels and dismantling sections of the interior. To the British team, it was as though the designers had built a mechanical cathedral, intricate, awe-inspiring, and utterly impractical for war. They noted how many of the Panther's innovations were both brilliant and self-defeating. The torsion bar suspension, for instance, offered excellent stability and comfort for the crew, allowing the tank to fire accurately even on rough ground. But the bars ran the full width of the hull, making it almost impossible to replace one without tearing apart the interior. The engineers compared it to an artist's painting on both sides of the same canvas. Elegant, but entirely unnecessary. During one of their final functional tests, the Panther was driven along a course simulating battlefield conditions. Mud, inclines, broken ground. The results were mixed as always. On smooth terrain, the tank was magnificent, fast, stable, and precise. But the moment it faced uneven or soft ground, its weight became its enemy. The suspension groaned, the tracks bogged down, and the temperature gauges climbed dangerously high. Within an hour, they were forced to halt again, steam pouring from the rear vents. The British recorded every failure meticulously. The cooling system, they observed, was far too delicate. The radiators, though large, were vulnerable to even minor damage. The fans that drew air through the engine compartment were prone to jamming from dust and debris. In a European battlefield choked with mud, smoke, and shrapnel, these flaws meant death. But even with its flaws laid bare, the Panther continued to command respect. It wasn't simply a tank. It was a symbol of how far human engineering could reach when unrestrained by practicality. The British team knew that German designers had built it not just as a weapon, but as a statement. Proof of technological supremacy, a declaration that no one could outthink German industry. Yet in pursuing that ideal, they had forgotten the first rule of war. Simplicity wins. The engineers also analyzed the production process. They discovered that the Panther required a staggering number of man-hours, upwards of 150,000 to complete, and needed specialized parts from dozens of suppliers across Germany. By 1944, Allied bombing had crippled many of those factories. Spare parts were scarce, logistics chaotic. The Panther wasn't just difficult to repair, it was nearly impossible to sustain in the field. In their final comparative analysis, the British placed the Panther side by side with the T-34 and Sherman. The difference was philosophical as much as mechanical. The Soviet tank was rough, even crude, but it worked. It could be repaired with a wrench, fueled from almost anything, and operated by barely trained crews. The Sherman, meanwhile, embodied the American industrial genius for quantity and standardization. Reliable, adaptable, easy to replace. The Panther, though superior in many technical aspects, could not compete with that simplicity. By the end of the trials, one conclusion stood unshakable. The Panther had failed not because it was weak, but because it was too strong for its own good. It demanded a perfect world that never existed. When the British team compiled their official report, their tone was almost mournful. They recognized the Panther as one of history's most impressive machines, but also one of its greatest cautionary tales. The war had proven that perfection on the drawing board was meaningless if it couldn't survive the battlefield. As they shut down the engine for the last time, the Panther stood still in the gray afternoon light, steam rising from its vents. It looked every bit the predator its name implied, powerful, elegant, and doomed by its own nature. The British chief engineer noted in his journal that evening, "If this tank were simpler, it might have changed the war. But as it is, it stands as a monument, not to power, but to pride." By spring 1945, as the war in Europe drew toward its end, the British engineers had turned their Panther testing project into something more than an analysis. It had become an autopsy of a dying empire's ambition. Every day spent with the machine told the same story, the pursuit of technological perfection without restraint. The engineers no longer saw the tank as a weapon. They saw it as a reflection of a nation that had engineered itself into exhaustion. The disassembled components lined the workshop floors, a mosaic of German precision. The Maybach engine gleamed under the lights, its metal surfaces still flawless despite months of hard use. The gearbox, taken apart bolt by bolt, revealed a labyrinth of interlocking teeth and delicate bearings. The welds along the hull were immaculate, symmetrical, exact. It was art forged in steel. Yet every part they examined confirmed the same fatal truth. It was too much, too fine, too demanding, too fragile for the realities of war. Reports from the front, now pouring in from Allied intelligence, described how these very tanks, the pride of Hitler's armored divisions, were failing en masse in the field. German units abandoned them daily for lack of fuel or spare parts. In Russia, hundreds had frozen in place during winter, their engines refusing to start. In France, many broke down before they even reached the battlefield. The British engineers now understood why. The Panther had been designed for an army that no longer existed, one with limitless resources, experienced crews, and control of the skies. When the British tested how quickly a Panther could be field-stripped compared to a Sherman or Cromwell, the difference was staggering. The Allied tanks could be serviced by a handful of men with standard tools. The Panther required specialized wrenches, hoists, and trained mechanics. In battle, such luxury didn't exist. A tank that couldn't be maintained wasn't a tank. It was a liability. One of the most revealing moments came during a simulated battle damage repair. The engineers fired controlled charges near the Panther's suspension and hull, imitating shrapnel impacts. The aftermath was devastating. The Panther's carefully machined systems, full of precision components, didn't absorb the shock. They shattered. Pipes bent, fittings cracked, and alignment was lost. The tank's structural integrity was superb, but its internals were a house of glass. In contrast, Allied tanks, built with looser tolerances and cruder materials, absorbed such punishment with surprising resilience. The deeper the British dug, the clearer the irony became. German engineers had built a machine to embody superiority, and in doing so, they had stripped it of flexibility. Every inch of the Panther was designed to function perfectly, and when it didn't, the whole system failed. It was not a tank for soldiers, it was a tank for engineers, built by men who could not imagine losing control of their environment. Even its production history was a story of contradiction. The British had access to German records that detailed the staggering effort required to produce each Panther. Skilled laborers worked by hand on complex assemblies. Components were shipped across the Reich from factories that were constantly being bombed. The process was so intricate that only a few hundred could be completed each month, while the Allies were producing thousands of Shermans and T-34s. This imbalance haunted the British analysts. They realized that Germany had poured its dwindling strength into machines that could never win a war of attrition. The Panther might dominate a duel, but wars were no longer decided by duels. They were decided by who could fight longer, move faster, and repair easier. The Germans, blinded by their faith in technology, had built a masterpiece of design that was doomed the moment it left the factory floor. By the time the last test concluded, the British engineers no longer viewed the Panther with contempt, but with a strange respect, the kind one gives to a fallen giant. Its failures were not those of incompetence, but of excess. It had been too refined, too ambitious, too dependent on conditions that never existed. The lead engineer wrote in his closing notes, "The Panther is a triumph of intellect and a failure of understanding. It was designed to conquer, but never to endure outside." The rain drummed against the roof of the workshop, washing away the last dust from the Panther's hull. The engineers stood in silence, looking at what was once the most feared tank in Europe. Now stripped of myth and reduced to metal, it was no longer a symbol of power, but of a lesson learned in the hardest way possible. As the British engineers finalized their months of testing, the Panther sat motionless, a silent monument to German over-engineering. Its engine, once the heart of fear across Europe, had been dismantled, analyzed, and catalogued piece by piece. In its exposed state, the tank seemed almost vulnerable, stripped of its mystique. Yet the story it told was not one of failure alone, but of a grand illusion, the illusion that complexity could win a war. The engineers compiled their findings into a detailed report. They wrote of its strengths: superb firepower, exceptional optics, thick-sloped armor that could shrug off all but the heaviest shells. But every advantage came with a cost. Each improvement introduced more maintenance, more precision, more points of failure. The Panther's gun, the mighty 75mm KWK-42, could destroy an Allied tank at over a kilometer. But its barrel required constant recalibration, and its ammunition was scarce. The transmission provided smooth power at high speeds, but required hours of careful alignment after every repair. It was a tank that demanded perfection from the imperfect world of war. The British compared the Panther's performance under controlled conditions to what had happened on actual battlefields. In Normandy, the Panther's debut had been terrifying. Its first encounters with Allied armor left Sherman crews shaken. But as the campaign wore on, reality caught up with design. The heavy weight caused constant track failures on the narrow French roads. The complex engines overheated in the summer heat. Mechanics struggled to keep them running, often cannibalizing parts from other damaged tanks just to keep one in motion. In contrast, the Shermans and Cromwells could roll forward day after day. They might not match the Panther one-on-one, but their reliability made them an unstoppable tide. While one Panther broke down, 3 Shermans advanced. And on the Eastern Front, Soviet T-34s swarmed in endless waves, their simplicity allowing them to fight through mud, ice, and chaos without faltering. When the British team recreated a winter startup test, mimicking the conditions that had crippled German armor in Russia, the results were stark. The Panther's engine required preheating, careful priming, and minutes of delicate handling. When rushed, it seized. When mistreated, it cracked. The team noted that under true combat stress, it was almost impossible to keep running in freezing weather. The irony was clear. The tank built to dominate Europe could barely function in the climate that defined its greatest battles. As they reviewed the last of the engine trials, the lead engineer wrote a note in the margins. The Panther is not a machine built for soldiers. It is built for engineers, and engineers do not fight wars. The more they studied it, the more the Panther seemed to embody the German war machine itself, a creation of brilliance, but trapped by its own arrogance. The designers had built a weapon that could outfight anything in theory, yet they had forgotten the battlefield was no place for theory. Dust, cold, panic, and exhaustion were enemies that no blueprint could overcome. The British mechanics began to reflect on their own designs. The Cromwell, the Churchill, the Comet. They weren't perfect. They broke down. They burned. They were crude in comparison. But they could be built fast, fixed anywhere, and driven by ordinary men. Those qualities had won the war, not elegance or precision. During the final test, the British fired up the Panther's engine one last time. The Maybach coughed, roared, and settled into its deep metallic growl. The entire workshop vibrated. It was a sound of power and futility, magnificent yet meaningless. The engineers stood watching as the exhaust filled the air, the heat distorting their view of the machine. They knew this tank, for all its craftsmanship, represented the end of an era. The moment when technological ambition had outpaced the limits of human endurance. When they finally shut it down, the silence that followed was almost sacred. The engineers looked at each other, and for the first time, none of them wrote a word. There was nothing left to record. The Panther had spoken for itself, a weapon too advanced to survive the very war it was built to win. When the last of the tests concluded, the British engineers began preparing the Panther for storage. They cleaned its hull, drained its fuel, and logged every component in meticulous detail. The tank that had once roared across Europe now sat silent under the gray English sky, its blackened exhaust pipes streaked with rust. For months it had been dissected and measured, its every secret exposed. Yet as the engineers stepped back and looked at it one final time, they could not escape a strange sense of admiration. The Panther, they realized, was more than a war machine. It was the embodiment of a mindset. It reflected the German obsession with precision and dominance, a belief that technical superiority alone could guarantee victory. Every bolt, every gear, every weld spoke of pride, but beneath that pride lay fatal blindness. The British saw that the very qualities that made it extraordinary also made it fragile. It was the perfect paradox, a predator that could not endure the hunt. The final inspection focused on the tank's logistics footprint. The engineers compared the resources required to operate the Panther to those of Allied vehicles. What they found was staggering. A Panther battalion consumed more fuel in a single day than an entire Sherman regiment. Maintenance crews had to transport crates of spare parts, special oils, and tools, all while Germany's supply network collapsed under Allied bombing. Each tank that broke down on the battlefield became a burden rather than an asset. In the chaos of retreat, many were destroyed by their own crews to prevent capture. Even in the controlled environment of the British proving ground, the tanks struggled to perform consistently. After days of testing, seals began to leak, bearings wore down, and the transmission emitted a grinding wail. The machine demanded constant attention, as though it resented being used by those who hadn't built it. The British noted this almost poetically in their report. The Panther is a beast that devours itself. Yet despite everything, there was no denying its power. When working as intended, it was a marvel. Its gun could pierce any Allied tank at long range. Its suspension glided smoothly over rough ground. Its armor shrugged off hits that would have shredded lesser machines. But perfection in brief moments of function was not enough to win a war measured in months and years. The engineers often found themselves comparing the Panther to its chief rival, the T-34. In many ways, the T-34 was its opposite, built not for perfection, but for persistence. It was crude, noisy, and far less refined, but it was reliable, and more importantly, it could be built in staggering numbers. While Germany struggled to produce a few hundred Panthers a month, the Soviet Union rolled out thousands of T-34s. For every German tank that failed, 10 Soviet machines advanced. This contrast fascinated the British observers. The war, they realized, had become a contest not of quality, but of endurance. And endurance was something the Panther, in Germany, could no longer sustain. By early summer, the engineers received orders to transfer the Panther to a museum for preservation. It was no longer a weapon of war, but an artifact, a warning from history. As the transport crews loaded it onto a flatbed trailer, its treads clanked like chains. The once glorious machine, designed to dominate battlefields, now looked weary, almost defeated. One of the engineers standing beside the road as the tank was hauled away reflected silently. In the distance, British factories were already building new generations of vehicles, simpler, faster, and easier to maintain. The age of over-engineered giants had ended. The Panther had proven one thing above all: even the greatest machines can fail when they forget the simplest truth, that war rewards those who adapt, not those who obsess. As the flatbed truck rumbled out of the proving ground, the engineers turned back toward their workshop, leaving behind the echo of a war that had ended in steel, smoke, and shattered ambition. In the months that followed, the Panther remained in British custody, studied not as an enemy, but as a lesson. Engineers, officers, and historians from across the Allied nations came to see it, to walk around its hulking frame, to peer into its engine bay, to marvel and shake their heads in equal measure. It had become a relic of a philosophy that believed engineering brilliance could overcome the chaos of war. But war, as the Allies had proven, bowed to practicality, not perfection. The Panther's post-war tests were methodical and unsentimental. The British Army recorded every detail: the complex overlapping road wheels that froze solid in mud, the gear ratios that overheated under strain, the fragile final drives that failed under combat stress. Each flaw was another paragraph in the final report that would circulate through Allied command. To the untrained eye, the Panther looked unstoppable. To those who had studied it, it was a masterpiece trapped by its own complexity. The final conclusions were both respectful and damning. The engineers acknowledged that the Panther's armor layout and main gun had set new standards for tank design. Its 75mm cannon, with its remarkable muzzle velocity, had forced the Allies to rethink their armor strategy. Its sloped armor had inspired future generations of tanks. Yet every advancement came at a price the Germans could not afford. The report's summary noted, "In the Panther, we see the paradox of the German war effort. A weapon too advanced for the conditions of its use, too fragile for the hands that wielded it, and too costly for the nation that built it." That phrase echoed through military academies for decades. The Panther became a cautionary example, not of failure in combat, but of a deeper flaw: the inability to balance ambition with reality. It symbolized how Germany's industrial genius had been consumed by its obsession with superiority. The engineers had sought to create the perfect tank, but in doing so, they had forgotten what made a tank truly great: simplicity, reliability, and endurance. As post-war Britain moved forward into a new age of mechanized warfare, the lessons of the Panther shaped its future designs. Tanks like the Centurion and later the Chieftain were conceived with a different philosophy: power balanced with practicality, strength tempered by serviceability. The British understood now that a weapon's worth was not measured by its sophistication, but by how well it could survive the dirt, the cold, and the chaos of battle. The Panther itself, after its final evaluation, was shipped to the Bovington Tank Museum, where it remains to this day. It sits in quiet dignity among the machines of history, its angular silhouette still commanding respect. Visitors often stop to admire its sleek lines, its imposing presence. Few realize that behind that beauty lies a story of failure born from brilliance. For those who understand its history, the Panther is not merely a weapon, it is a warning. A warning that in war, every advantage carries a cost, and every innovation demands balance. It is a reminder that technology alone cannot win battles. Men, logistics, and adaptability do. As the years passed, the engineers who once studied the Panther grew old and retired. Some would later reflect in interviews that working on the captured tank had changed how they viewed warfare entirely. They had witnessed firsthand how even the most formidable machine could be undone by the smallest flaw: a frozen gasket, a broken bearing, a drop of oil too thick in the cold. The Panther's legacy endures not because it triumphed, but because it failed in ways that taught the world what true engineering in war meant. It remains a symbol of human ambition, both magnificent and misguided, a steel monument to the belief that perfection can exist in the furnace of combat. And in that paradox lies the enduring power of its story. The Panther was a masterpiece that defeated itself, a creation that, in trying to be flawless, revealed the beauty of imperfection. If you enjoyed this video, don't forget to like, comment, and subscribe for more World War II stories.